Hello to you inquiring minds. Mr. Chantry here, your neighborhood planetarium director, with the August 2021 edition of Evening Sky Excursions, where I show you what to look for in the sky this month. You can always visit the Planetarium website at www.methacton.org/planetarium and follow us on Twitter at MST Planetarium for more space information, news, and planetarium happenings. We are currently anticipating that those planetarium happenings will include the return of public shows each month and the return of laser light shows in December. This month, we can easily spot the summer triangle. We can use the summer triangle to find two visually stunning planets that are opposite of the sun in the sky. We will check out some great targets for those who may just be learning to use binoculars and telescopes. And finally, we will talk about this month's true blue moon. We begin with looking at some stars in the sky. With the longest day of the year, the summer solstice, behind us back in June, the days are getting shorter. We will lose about 1 hour of daylight throughout the month of August. You should see the stars making their nightly appearance by around 8:15 to 8:30, and the sky will be sufficiently dark for observing by about 9 o'clock here in the beginning of the month, and by about 8:15 at the end of the month. The summer triangle is an asterism made up of 3 bright stars that form an obvious triangle shape in the sky. The brightest star in the triangle, and the brightest in our summer sky, is Vega, which will appear to be just about over your head as you look up. Go out and look straight over your head, and the brightest star that you will see there is Vega. To the left or east of Vega, about 2 widths of your fist held at arm's length, is the slightly dimmer, but still very bright, Deneb. Then, about 3 fist widths held at arm's length below is the star Altair, which is slightly brighter than Deneb and slightly dimmer than Vega. If you imagine lines connecting these 3 stars, you have the summer triangle. This 3-sided asterism will continue to be prominent in our evening sky until December, when 3 different stars that form the winter triangle will be the bright stars in our skies. Each of the 3 stars in this well-known asterism is the brightest star in its own constellation. Vega, almost directly overhead, is the brightest star in the constellation Lyra, the Harp. Deneb is the brightest star and marks out the tail feathers in the constellation Cygnus, the Swan. The third corner of the triangle, Altair, is the brightest star in another bird-shaped constellation, Aquila the Eagle. If you enjoy finding constellations in the sky and want to find them all, there is a link in the description below for a full map of this month's sky from skymaps.com, which is a great resource for learning your way around the constellations of the nighttime sky. Not only does the summer triangle mark out these 3 constellations, it is also a good reference point for where to see the Milky Way in our summer sky. Unfortunately, in our area, light pollution has made the Milky Way all but impossible to see, except for on very rare occasions. But if you're using these final weeks of summer to travel away from the light pollution in our area, like the mountains or somewhere out west, the Milky Way goes from the horizon in the south, up through the summer triangle, and back down to the horizon in the north. It's an amazing sight that, unfortunately, many people no longer get to experience, so I highly recommend seeking out somewhere to see it. Back to what we can see. If you use the summer triangle like a big arrow pointing towards the ground, you will come across a point of light that looks almost as bright as Vega. And to the left or east of that point of light is another point of light brighter than Vega. These are not stars. These are planets. And not just any planets, but 2 of the most visually stunning planets to view, Jupiter and Saturn. Jupiter is the brighter of the pair on the left or east, and Saturn is the dimmer on the right or west. Both of these planets reach what astronomers call opposition this month. Opposition is when planets, or any other celestial objects, are opposite of the sun in the sky. The sun reaches its highest point in the sky at noon, and planets at opposition are at their highest point in the sky at midnight. Opposition typically begins the period when planets become most easily visible in the evening sky. These two planets will be sticking around and will be easily spotted in our evening skies for the next 5 to 6 months. These are amazing and fairly easy targets for anyone who is just starting to explore the night sky with binoculars or a telescope. Point just about any pair of binoculars at Jupiter, and you should see up to all 4 of the Galilean moons, discovered by Galileo when he first turned an early telescope to the skies and observed Jupiter in early 1610. Galileo also pointed his early telescopes to Saturn, but since the magnification of his first telescopes were barely as powerful as the typical binoculars found today, he only noted that Saturn looked misshaped, or looked kind of like a planet with ears. If you point a modern-day telescope at Jupiter, even a small scope, you should be able to see the stripes, or what astronomers call equatorial bands, formed by the clouds in Jupiter's upper atmosphere. Turn that scope to Saturn, and you will see the planet's famous rings that make it just visually stunning, and my personal favorite object to view in the nighttime sky. Like I said before, these two visually stunning objects will be easily visible in our evening skies for the next 5 to 6 months. And if you would like to get into the hobby of amateur astronomy and telescopes, I've set up a page on the Planetarium website, www.methacton.org/planetarium, under the More tab called A Guide to Telescopes and Buying. Please check this out and do some research before simply purchasing a department store telescope. These are often not of good quality and can be frustrating and even a deterrent for beginners of this fun nighttime hobby. You can also find links to local astronomy groups in the area that have star parties, where you can go and look at these views through other people's telescopes. If you already have or decide to enter the world of telescopes this month, I'll give you 2 great targets back up in the summer triangle. Can you still find the summer triangle? Here it is. Near the center of the summer triangle is a star in the constellation Cygnus that marks the head of the swan. This star is called Albireo. Depending on the light pollution from your observing area, this star should be faint, but still visible. If you point your telescope at this star and get enough magnification, you will be able to see that this star, that looks like just one point of light to our eyes, is actually 2 stars. Recent astronomical science in 2018 revealed that these 2 stars are not what we call a true binary star system, which are 2 stars that are gravitationally bound and orbit each other. These 2 stars are actually a coincidental binary star system, which is 2 stars that just appear to be close together but do not gravitationally orbit each other. There are lots of binary stars, both true and coincidental, in the sky, and they're some of the favorite targets for amateur astronomers to hunt down and observe. If you're able to locate Albireo relatively easily and would like more of a challenge, try finding M57 in the constellation Lyra the Harp. If you recall, Lyra is marked out by the brightest star in the summer triangle, Vega. Vega is by far the brightest star in this small constellation. The rest of the constellation is a parallelogram of 4 stars that appear below Vega. To locate M57, the ring nebula, you have to look between the 2 lower stars in the parallelogram. If you point your telescope here, and the viewing conditions are good, you may be able to observe a small fuzzy donut shape in the sky. This is the Ring Nebula, a cloud of dust and gas left over from the death of a star. Here in this simulation and in online photos, the Ring Nebula looks like an amazingly colorful and large object. But this is a simulation, and astronomical photos are a whole different bag of worms to get into. In a typical amateur telescope, it will appear a very faint but distinct donut-shaped fuzzy spot. It is really cool when you're finally able to track it down and see it with your own eyes after multiple attempts. Even without a telescope or binoculars this month, you will be able to spot the blue moon on August 22nd. Now, first, and most importantly, the term blue moon does not mean that the moon will appear to be blue in color. There are very, very rare instances where particles in the atmosphere from a volcanic eruption or wildfires can affect the color that the moon appears. As light from the sun reflects off the moon's surface, travels through the Earth's atmosphere, and hits your eyes, if there are enough particles of a certain size in the atmosphere, it can scatter some of the other colors of light and make the moon appear red, green, or even blue. This, however, is a very rare event. It is not what will be happening on the 22nd, and it is not what a blue moon actually is. There is actually a long and changing history of the term blue moon, and I recommend Googling it and reading some of the articles. It's very interesting if you're into this type of folklore. When we talk about what a blue moon is, in the recent past, it is generally accepted as the second full moon in a calendar month. This occurred last year in October, with the blue moon occurring on Halloween night. The moon has a synodic period of 29.5 days. Think of it as the time from one full moon to the next full moon. Most of our calendar months are 30 or 31 days. Because of this, very rarely we do get 2 full moons in one calendar month. The first full moon would have to occur in the first day or so of the month, and the second would fall on the last day or so of the month. This definition of blue moon, 2 full moons in one calendar month, is actually a misinterpretation of an older definition of blue moon. The older definition, or what I like to call the true blue moon, is what will be happening this month on the 22nd. The true definition of blue moon is the third blue moon in a season that has 4 full moons. The year is divided into 4 seasons, defined astronomically by the solstices and equinoxes. There are 12 months in a year, divided by 4 seasons is 3 months per season, and typically 3 full moons. But every 2.5 years or so, you will get a situation like we have this summer, where there are 4 full moons between the solstices and or equinoxes. Summer officially began with the summer solstice on June 20th at 11:32 p.m. And it will end with the autumnal equinox on September 22nd at 3:21 p.m. We had full moons on June 24th and July 23rd. The third of the summer will be on August 22nd, and the final full moon of summer 2021 will occur on September 20th. With the August 22nd full moon being the third of 4 this season, it is by the original definition a true blue moon, but most likely will not appear blue in color, and is not the typical blue moon that people talk about anymore. Blue moon. Anyway, in astronomy, just like in life, things often change over time. Sometimes ideas and definitions, like the blue moon, are misinterpreted and take on new meanings. Sometimes our understanding of the universe, like the double star Albireo, is changed by new investigations. Sometimes the world appears to be irreversibly changed for the worse, like light pollution blocking the spectacular view of the Milky Way for most of us. It can be difficult and even overwhelming sometimes to sort through all of the history and data to find the real story and accept the way the world is. While sorting through data, trying to understand history, and trying to understand how the world works is very important, sometimes, maybe like once in a blue moon, It's also important to just sit back and enjoy our view of the amazing universe in which we live. So this month, as the summer season begins to wind down, be sure to get outside, look up, be amazed by our universe, and most importantly, be excellent to each other.